All right, today we're jumping into a real scientific detective story. We're on the hunt for a major culprit in air pollution, an invisible gas called sulfur dioxide. For years, scientists trying to track it across the Middle East knew something was wrong. Their evidence just wasn't adding up. So today, we're going to see how a brand new technique finally cracked the case.
So let me ask you this. How do you track a ghost? It sounds impossible, right? Well, that's pretty much the challenge that atmospheric scientists are up against. Their suspect is a completely invisible gas, and the crime scene, it's the entire sky. They know what's out there, but figuring out exactly who or what is responsible, now that's the real mystery.
And this whole mystery is unfolding in the Middle East, a region that's not only home to booming industry, but also some of the worst air pollution on the planet. You've got so many potential sources all packed together, so trying to untangle who's emitting what becomes this giant, complicated puzzle.
Now, our main suspect, our invisible ghost, is sulfur dioxide, or SO2. It's a nasty gas that gets pumped out when you burn fossil fuels for things like power plants and oil refineries. And it's a real problem. It's a key ingredient in acid rain, it causes serious health issues, and it even messes with our climate by creating these tiny particles that can change how clouds form.
So, where did this investigation even begin? Well, it all started with the evidence itself. You see, for years, scientists had two main sets of clues to work with, but the problem was they told completely contradictory stories.
Let's take a closer look at these two sets of clues, because they were both seriously flawed.
Okay, so on one hand, you have the bottom-up method. Think of this like a paper trail. It's based on data that companies and countries report themselves. The big flaw here? This data is often old, it's incomplete, and surprise, surprise, it almost always underestimates the real pollution numbers. Then, on the other hand, you have the top-down method, basically the view from space, using satellites. Now, this is great for getting the big picture, but it has a really hard time telling the difference between pollution plumes that are close together, and because of that, it tends to overestimate the emissions. So you're stuck. One clue says the numbers are way too low, the other says they're way too high.
And we're not talking about a small disagreement here. As the researchers themselves put it, they found fundamental inconsistencies. Basically, the evidence they had was so contradictory, it was almost useless. They had hit a wall, and they knew they needed a totally new way to investigate.
And this is where things get really cool. That dead end led to a major breakthrough, a completely new forensic technique designed to finally get to the bottom of this.
And that solution has a name: inverse modeling. It's a really powerful idea. Instead of starting with what you think a factory is emitting and then guessing where that pollution goes, this method does the exact opposite. It works backward. The best way to think about it is like figuring out a secret recipe. Step 1, you taste the final dish. That's our satellite snapshot of all the SO2 pollution hanging in the air. Step 2, you remove the background flavors. You use a computer model to figure out and subtract all the general, widespread pollution from things like cars and ships. Step 3, you isolate the key ingredients. You actually model how the smoke plume from every single one of the 134 major industrial sites would spread through the atmosphere. And then, here's the magic. Step 4, you find the perfect match. The model works backward to figure out the exact amount of pollution that had to come from each of those sources to create the dish you tasted in Step 1. It's brilliant.
So, after running this incredible new model, what did it reveal? Well, it didn't just tweak the old numbers, it completely changed our understanding of what was going on. First off, remember that top-down method, the view from space? It turns out it had overestimated the emissions from these big industrial sources by a massive 41%. That problem of not being able to separate the plumes really threw the old numbers way off.
But here's the kicker. That bottom-up method, the one based on self-reported numbers, it had underestimated pollution from other sources by a staggering 100%. The real number was double what the official paper trail was suggesting.
So you've got this huge overestimation on one side, and an even bigger underestimation on the other. When you balance it all out, the net result was actually that the total pollution from these 134 major sources was 18% lower than what the old models had suggested. And here is the most important part. This new pollution map isn't just another guess. It's demonstrably better. It closes the gap with what we can actually observe from space with satellites by 21%. It's a much, much closer match to reality. And all this new accuracy means that for the first time, we can create a reliable ranking of the biggest emitters. The study found that Iran is the largest source of SO2 in the region, followed by Turkey and then Saudi Arabia. This is the kind of clear,
actionable data that was simply impossible to get before.
Okay, so we've got these new super accurate numbers, but why does it matter? Why is this so important? Well, this isn't just some academic exercise. Getting this right has huge consequences in the real world.
I mean, think about it. Knowing exactly where pollution is coming from is a total game changer. It helps governments create smarter regulations to protect people's health. It makes our climate models way more accurate, which helps us understand our planet's future. It even improves the daily air quality forecasts you might check on your phone. And maybe the biggest thing, this method is a blueprint. We can now use it with newer, even more powerful satellites to monitor pollution just about anywhere on Earth, holding emitters accountable in a way we never could before.
So, the scientific detectives have cracked the case. They've given us this incredible new tool to see the invisible. And that leaves us with one final big question. Now that we can finally track these pollution ghosts with such amazing precision, where in the world should we point this new lens next?